we know that once equilibrium has been established, the rate at which the forward reaction progresses is equal to the rate of the reverse reaction, and the ratio of product concentration to reactant concentration is constant in a value called Kc for a specific temperature. Now, we know that it is possible to make changes to a reaction while it is at equilibrium, and Le Chatelier's principle governs the response to that change, where Le Chatelier's principle essentially says the reaction tries to undo the change that you have made. So the change we are looking at now is a temperature change, where we are going to say what would happen if we were to increase the temperature of this reaction while it's at equilibrium. So the first thing to notice here is that this reaction, the forward reaction here, is exothermic, meaning the reaction mixture heats up for the forward reaction. Now we know that Le Chatelier's principle says the reaction is going to try to undo the change that we have made. So the external change is that the temperature is heated up. So the reaction is going to try to cool itself down by favoring the endothermic direction. And as we can see here, the endothermic is the reverse reaction, which means that temporarily the rate of the reverse reaction is going to be greater than the rate of the forward reaction, once again until equilibrium is re-established, where the rate of the forward is equal to the rate of the reverse reaction. Note though that a temperature change does mean that your value of Kc will change. We can determine how that value of Kc changes by noticing that by favoring the reverse reaction, we are decreasing the concentration of ammonia, increasing the concentration of hydrogen and nitrogen. What we can see that does is that the numerator of this reaction is decreasing while the denominator is increasing, which means that this number, the Kc number, is getting smaller. So the new Kc value is going to be less than the original Kc value when the temperature is increased. We can do another example where we see what would happen if the temperature of this was externally decreased. Once again, Le Chatelier's principle says that we will favor the direction that undoes that change. So we tried to decrease the temperature. This reaction is going to try to counter that by increasing its temperature, meaning favoring the exothermic reaction, which in this case is the forward direction, which means that temporarily the forward reaction proceeds at a greater rate than the reverse reaction. The effect that this has is that the concentration of ammonia increases while the concentrations of nitrogen and hydrogen both decrease. We can see the effect that that has on our value of Kc here by seeing that the concentration of our numerator increases while the denominator decreases, which means that our value of Kc is going to increase, or we can say that the new value of Kc is going to be greater than the original Kc value. So this is the only change to a reaction that does produce a change to our Kc value, which is why it is important when specifying a reaction's Kc value to specify the temperature, because it is specific to that temperature. A quick note on the effect of a catalyst. We know that a catalyst provides an alternate path for the reaction to proceed. What a catalyst does is it increases the rate of the forward reaction exactly the same amount as it increases the rate of the reverse reaction. So a catalyst does not disturb equilibrium and therefore has no effect on our Kc value.